This lesson is going to be about sound and light energy, and the learning target is to be able to describe how the properties of a wave affects its energy. The two types of waves we're going to be looking at are sound and light. They're two very different types of waves. Sound is a longitudinal wave which travels through matter. It's a mechanical wave. It needs particles to be colliding in order for it to travel through matter. And light is an electromagnetic wave which can travel through empty space. And although these are very different from each other, there's certain properties that they both have in common. They both have frequencies, they both have wavelengths, they both have amplitudes, and they're both affected in actually the physical characteristics of sound and light that we see are both affected by things like frequency and wavelength and amplitude. And that's what we're going to be getting into today is how do we, how do the properties of sound and light change when the properties of their waves change as well. And so that's something we're going to be looking at today. So sound, if you want to, a really good website to be going to is the signalgenerator.sciencemusic.org. They have a great generator where you can look at how sound changes based on the frequency and the amplitude of the waves. And you should really stop the video and go to this website and look at that if you have not done so already. When we look at sound and how wave properties affect sound, we can see that the frequency of our wave, whether it is a high frequency wave or a low frequency wave, that changes the pitch quite a bit. This one right here is going to be a very high pitched noise, and this one here is going to be a very low pitched noise. So the low pitch depends on the low frequency, and the high pitch, I won't do that one. The high pitch depends on is affected by a high frequency, and so that's how the frequency affects our sound. It depends on whether we're singing a high or low note. The amplitude again is the height or the level of disturbance of these waves. So we have an amplitude of this one right here versus this right here. This is going to affect the volume because remember, amplitude means energy and it affects how much energy these waves are carrying. And so this is going to tell us what our volume is. If we have a high amplitude, we have a lot of energy, and that sound is going to be sounding louder. It's going to have a higher volume. And if it's a low amplitude, it's not carrying quite as much energy, and so it's going to have a low volume. And so the wave properties, the way that the waves are shaped, directly affects the sound that we hear, whether it's the frequency determining our pitch or our amplitude determining the volume of that sound. Now, if we look at the electromagnetic spectrum, or if we look at light, light is a part of the electromagnetic spectrum, and the visible light that we see is one small part of this spectrum. We have things like radio waves, microwaves, infrared waves, ultraviolet rays, X-rays, and gamma rays. And all of them travel at a speed of 300 million meters per second. You might see something like this, 3 times 10 to the 8th meters per second. All of them travel at the same speed. And one thing that you can remember is that if the speed stays the same, our frequency and our wavelength are inversely related to each other, right? As long as we keep that speed constant. And so you can see that our wavelengths down here on this side are very long. And over here, as our frequency increases, our wavelengths are very, very, very short. And so our electromagnetic spectrum is classified based on those properties of those waves. We have our radio waves have the longest wavelength and the lowest frequency. Then we have microwaves, and then we have infrared. These are all waves that we can't necessarily see. You might be familiar with infrared because this is what you normally see on like I don't know if you're like a Call of Duty gamer or something like that. You would see it on a thermal scope. It's the waves that matter gives off. And we have ultraviolet rays, have a little bit more frequency. They're more frequent. They have a shorter wavelength. We have our X-rays and we have our gamma rays. And our gamma rays have the highest frequency and the shortest wavelength out of all of the different types of electromagnetic waves. But this, again, just this small part is the part that we can see. Everything else are waves that we cannot see. And the properties of these waves are, and their uses really, is all dependent on the properties of these waves. It's how long their wavelength is and how high their frequency is depends what these waves can do. We use these waves for very different things than we use X-rays, and it's dependent on the properties of those waves. And the same pattern of the properties of the waves affecting what we actually see, hear, how we interact with these waves is true for visible light as well. Light is that small section of the electromagnetic spectrum, and we have our longest wavelength is down here on the reds, and then we've got our blues and our purples have a much higher frequency, a much shorter wavelength. And so as the waves change, as the properties of the waves change with their frequency and their wavelength, the actual colors that we see changes. And so that's how what we observe and what we interact with and how we deal with these waves changes based off of their properties. So the frequency of light affects the color that we see. And so just like with sound, the amplitude also has an effect on how we interact with light. Amplitude, again, is how much energy that these waves are carrying. And so it's going to affect the brightness. It's how bright we see that and how intense that light is. And our frequency, again, just like with pitch, in sound waves determines our color and energy. So if I was going to compare this to sound, if I change my frequency, that affects my pitch. And for sound, if I change my amplitude, that affects my volume. And it's all about how much energy those waves are transmitting. And so I hope that this helps to understand how the properties of waves affects the energy.